Okay, in this video, we'll discuss this question from optics chapter in Pathfinder. And if you see this question for the first time, it's very hard to recognize that this was an optics question because there was nothing related to light in this question. They're just showing one particle, and we have to find number of collisions this one will do inside and the closest distance that it will approach towards point O. So actually this one just goes like this and again comes back. So we have to count how many collisions that are happening and the least distance between point O and the particle throughout the motion. So straight away I'll go to the solution. If you're seeing this question for the first time, pause the video, try it out yourself, and then you can continue with the solution. So here I'm going to use the property that all elastic collisions will behave like light reflection, and one more important point here, gravity is neglected. G is negligible. We are doing this in a gravity free space. So logic is going to be pretty simple. If you have a perfectly elastic collision, light behavior on this one will be same. If it falls with u velocity, again it will go with u speed. So theta, or if this is I, this is r, I will be equal to r if this is an elastic collision, given that the surface is also smooth. Here the surface is also smooth and collisions are elastic, so I can treat this as light reflection. First particle went like this, then it bounced and reflected in this way, and this theta 1 is equal to this theta 1 because of law of reflection. Now this full cone I'm just flipping here. Okay, now if you observe, or you can tell that you're just treating this like a mirror, so I can tell this length and this length will be same and it will be a proper straight line. Okay, so instead of drawing this reflection here, I can draw it here. Okay, though the distance traveled is exactly same, and if you observe carefully, distance from point O is also not changing. This distance are exactly equal. So instead of analyzing this motion, I'll analyze this motion, and same logic you can repeat again. This blue line that you're seeing is actually happened here, so you can take it here. Again by the same logic, treat this as mirror. This one will form image here, so this one again will become a straight line. Again this sky blue one again goes in this way. So overall motion of this can be analyzed as a straight line motion. So instead of dealing with this motion, I'll start dealing with this motion. So here this is traveling in a straight line. If you want minimum distance, we should just drop a perpendicular, and that perpendicular is minimum distance. So this is line of motion of P. So minimum distance means you should just drop a perpendicular, and this distance is given as x. So this is alpha 90. So this can be easily written as x sine alpha, and x value in the question it is given as 10 centimeters. So I have substituted 10, and alpha value is given as 37 in the question itself. So minimum distance between O and the particle is 6 centimeter. Though I am finding for the straight line, you have to understand that throughout the motion, distance of the particle on this straight line is same as what was actually happening here. Next, if I want to find the total number of collisions, if you observe carefully, every time it encounters this surface, one reflection happens, and that one only we are just taking it here, and next one more reflection happened, that we are taking it here. So in this motion, if you observe, first one was at this angle beta by 2, next beta, so every time beta angle is increasing for one collision. So till when this will happen? So particle is moving like this. Let's say these surfaces crossed this parallel line to this line of motion. After this, even if you take a surface, this one is not going to hit it. So the maximum limit is beta can be till this surface, okay, for it to collide. So here, if this was alpha, this is also alpha because these two are parallel lines. And for us, this beta line should not cross this dotted line. So this full angle, I can simply write it as 180 minus alpha. And here, if you have n reflections, you can see that this full angle is n minus 1 by 2 into beta. and this must be less than 180 minus alpha if you want a collision to occur. Okay, so this 180 minus alpha must be greater than n by n minus 1 by 2 into beta. Okay, you can substitute n is equal to 1, you'll get beta by 2. N is equal to 2, you'll get 3 beta by 2, which is sum of these two. N is equal to 3, you'll get 2 beta plus beta by 2. So that's what we have written here. So I got n is less than 180 minus alpha plus by beta plus 1 by 2 just by rearrangement. Next, I am just substituting alpha and beta values that are given in the question. So I got n is less than 7.65. Now we know that n must be an integer because number of reflections cannot have decimal part in it. So total number of reflections that are possible as 7. Okay, I hope you enjoyed the solution.